Good morning students. In the last class I taught you about the one of the most important topic, that is comparison of vehicles, right. In this class I am going to teach you about the resistances. What is meant by resistance? Is the opposite force. Opposite force is the backward force. It is called as resistance, right. Here we are going to design a vehicle. For that we need to consider some resistances. What are the resistances will acquire while moving the vehicle? What are the resistances will acquire while moving the vehicle? What are the resistances means? Air resistance, rolling resistance, as well as the gradient resistance. The three type of resistance will acquire during the vehicle moving. Right? So we need to calculate the resistances, and based on that we need to design that particular vehicle. Then only we can able to move the vehicle effectively. Right? So I am going to teach you this topic, resistances. Already we know what my resistance is the backward force, otherwise opposite force. While moving the vehicle forward direction, the resistance will acquire in the opposite direction, reverse, right. Here first one, air resistance. This air resistance takes place while the motion of the vehicle moving forward direction, the air move in the backward direction of the vehicle, right. That resistance is called as air resistance. This will happen depends upon these conditions: density of the medium, density of the air, and size and shape of the vehicle body, and aerodynamic drag coefficient, and velocity of the vehicle. Last one, acceleration due to gravity. These are the things we need to consider in this vehicle design. We need to consider these important things in the vehicle design, right. Here we have plotted a curve for air resistance with respect to vehicle speed. It should be like this curve formation. How we will get the curve formation? Due to that, we need to utilize this equation form. We need to solve this equation form, and we need to form that curve formation. In the design parameter. Here we know the value of C rho A V. V is the velocity, A is the area, rho is the density, C is the constant value. Then G is the acceleration due to gravity. Right. Already we know all the things. Here we can simplify this relation. This relation into like this form. How mean? Instead of 0 divided by 2g, we can write this Ka. That is the constant value. That is the coefficient value. There is a constant. Here I took that value 0.032 for the modern cars. I selected a modern cars. For modern cars are like this only, right. Each and every vehicle have certain standard values. That I noted here. For the perfectly streamlined body 0.0013 Ka value. The Ka value for early passenger cars, olden cars, the value will be 0.0526 to 0.015. 0.0015. This is the limit. Then for the modern cars, the value will be 0.0032. For the racing cars, the value will be 0.00245. For the trucks, heavy vehicles, 0.0047. For double decker buses, 0.006. These are the values for the standard values for the KA. Standard values for the KA, right? This KA will be used only for the air resistance. Find the air resistance, right? Next I am going to teach you a rolling resistance. What's my rolling resistance? Rolling resistance is same as the road resistance. Rolling resistance is same as the road resistance, right? How it will take place? Resistance offered by the road surfaces. Resistance offered by the road surfaces to move the vehicle. Road resistance, right? This will happen depends upon the nature of the road surface, type of tire, weight of the vehicle and vehicle speed, right? Whenever we are using a highway roads, there is a very less amount of resistance will be there because due to the good surface finish, right? Good surface finish of the road surface. Suppose in the rural area and in our municipality area, road surface will be get damaged. So there will be a more resistance. There will have more resistances, right? That we need to consider here. For finding the road resistance value, we need to substitute this equation A plus BV into W. A and B is the constant values. A and B are the constant values. And W, what's my W? W is the gross weight or normal weight of the vehicle, right? After substituting those values, only the variable will be velocity and gross weight. Variable will be velocity and gross weight. When we are substituting that values here, we will get the changes and make them to plot. Okay, right? Okay, right? Finally, we got the rolling resistance values. After that, we need to consider. Here also we have different conditions, right? Different values. The value of rolling resistance. This is the standard values. This much only we can able to use. Suppose it will be more or less means it will get some difficulties to drive. So we need to avoid that. Finally, gradient resistance. What is the gradient resistance? When you are driving a vehicle in a slope area, hills area, that time there is gradient resistance will occur. Right? When we are driving or moving into the hill areas, otherwise slope areas, right? Slope areas, the gradient resistance will occur. Why means the total weight will act is perpendicular, right? That time there is a gradient, the total gradient weight will occur here, right? For finding the gradient resistance, the formula will be W sin theta. The load, forward direction load and sin theta. Already this concept you studied in the engineering mechanics itself, right? Already you found these values, resistance values in the engineering mechanics itself. Same concept come over here, right? Then finally we need to find the total resistance. Up to this we found the air resistance value separately and rolling resistance value separately and gradient resistance value separately. Finally, we need to add all the things, sum of all the resistance, sum of air resistance, rolling resistance and gradient resistance. This is the total resistance. This is the total resistance, right? Sometimes the vehicle is moving in the level road. Level road means smooth surfaces, not a hill area, not a slope road, just level road, just a level road. We need to apply only for the air resistance and rolling resistance for the total resistance. Sum of the air resistance and rolling resistance it will be applied for the total resistance. Suppose it is a hill area, otherwise slope road, we need to consider the gradient resistance. We need to consider the gradient resistance. Okay, right? In the next class, I will teach you about the performance of the vehicle body, vehicle design. Thank you.